If there's anybody out in this world who might have a computer box that's logged into Sakai that can take a look at the most recent announcement to make sure we're live and we avoid that snafu from, oh, so long ago. No. I want to perform a magic trick. Just learn this on last night. All right. It does require a little audience participation though. Yeah. I can make myself shrink. All it requires you to do is close your eyes. I can't show you how I shrink. Anybody wants to be amazed? Ready? All right, close your eyes. All right, you know them. I'm getting on the shore, and then no, I absolutely can't do that. That's basically me saying if none of you know who Steve Martin is. Steve Martin's a funny guy. I just got done reading his book, one of his memoirs. He's hilarious and tells stories about how he got his start in stand-up performing tricks like that. That was funny. Decades ago. I still think it's funny, but not when I do it. It's funny when he does it. So if you actually want to laugh, check out some Steve Martin stuff. Hey, it's 4:30, I think. I don't know. Let's get started, shall we? Let's do it. Here's the story. Make sure we're live. I think we're live. We got 41 questions in Module 7. These 41 questions, I think it is, they won't take us the whole time. But what we can do with some of the rest of that time, if anyone's interested, is that there are now practice assignments posted in Module 7 and Module 8. Those practice assignments are not conceptual so much as they are a series of examples that take you step by step through either the hypothesis testing or confidence interval creation process. So I want to do these 41, and there are a lot of like these questions that we were talking about, maybe having a little more struggles, that stuff with. We'll get those, and then if we want to practice more problems, we spend most of our class time working on problems anyway. We want to use it some more. I might hard stop at 6:15, so I get some dinner before Go Friars tonight. Y'all better be there. And well, let's get started. Yeah. Question 1. The null hypothesis is the no effect hypothesis, not to be confused with the no effects hypothesis, which is a great hypothesis. The no effect hypothesis, referred to as the research hypothesis, the relationship researchers are interested in, or is denoted, or is denoted as H1. All right, how about this? What is the answer? A is the answer, right. What's a synonym for the research hypothesis? It starts with the letter A. Alternate hypothesis. Yeah. That'll earn you most of the points there. The relationship the researcher are interested in should be the research hypothesis, and H1, well, we tend to use HR, but H sub 1, H1, HR, HA are all synonyms, but 1 is A. Question number's not on here. Shoot, Jeff. 2. How do we denote the null hypothesis? H sub A, H sub O.
Autofocus, autofocus. Autofocus.
All right. What's the symbol for the null hypothesis? Who's that in the back? Can't see that far. Hey, Fabian, what's happening? What's the symbol for the null hypothesis? Yep. 0 as in null, as in nothing, as in not. So H sub 0, subscripts are tough in Sakai. H sub 0, that's our null hypothesis. H sub A or H sub 1, both of those would as well be research hypotheses. H sub N, I think, is the chemical symbol for caninium. Question 3. Why do researchers start with a no effect hypothesis and then try to reject it? Why? Why is that a strategy? Ernie. C. I don't speak Spanish. Thank you for trying.
It's the study, the student studies know that unless there's evidence.
So in broader terms, and you're correct. Again, the no effect is not what researchers are trying to establish, and there's nothing convenient about statistics. And well, boosting the probability of accepting some hypothesis might be, oh, if we were to change our confidence level or our alpha, if we're doing a hypothesis test, it's alpha. But this is innocent until proven guilty. That until you tell me that something might be different, I assume everything is the same. And that's what a good researcher, or I'd like to say human being, does, is assuming that we're all more or less the same. If you have any sort of empathy, then you would recognize that we're all just crazy humans trying to get along in a crazier world. When we're looking for effects or differences or anything like that, it's because you identify something which might be different, and then you use statistics to investigate. But otherwise, you start with the assumption that everything is the same, unless you observe otherwise, at which point you need an awful lot of evidence to reject the null. You get to control how much evidence that is with your alpha, but you start with the idea that everything is the same. Until you collect enough evidence to say, you know what, everything's not the same, I believe that there is something real. 3 is C. 4. The alternative hypothesis. Oh, I guess our author does use that language. Alternate, alternative. Allie, I stand corrected. And crooked as well. The alternative hypothesis. What is the alternative hypothesis, or the research hypothesis, or the alternate hypothesis? Who can give me some sort of response here? Keep it moving, Drew. I'm going to let all you drive. So if Drew, you want this is all yours today. What do you got?
States the relationship where researchers are interested in.
Yeah. So we could say it's the research hypothesis, or research, depending on where you're from. The research or research hypothesis is the thing that we are interested in. The null hypothesis is everything else. Whatever this is, 4 is bravo. Cool. 1 page down, some more to go. Questions? Feels like 10% to me. All right. I hope that one was big. So now we have these questions about type 1 and type 2 error. Type 1 error occurs a certain time. Type 2 error occurs a different time. But a type 1 and type 2 error cannot occur at the same time because they can only occur when specific things happen. What must have occurred, let's say, in the statistical test in order for a type 1 error to be possible? Right, so we have to, as a result of the hypothesis test, say we reject the null and accept the research. That's the first condition which must be met in order for a type 1 error to occur, is that we reject the null and accept the research. Under what circumstances would this be a type 1 error?
Think about reality in this point. We have rejected the null, accepted the research. Abby, what must be true about the research? Yeah, that we're wrong. It's an error because you were wrong. Wrong about this being correct. So the first condition which must be established for a type 1 error to occur is that you must reject the null. The second thing that must be true is that you're wrong. I think about it like this. Haven't had this discussion in class much about type 1 and type 2 error. But type 1 error, we'll see this later, is alpha error. Type 2 error is beta error. A, B, alpha, beta, like the alphabet. I say type 1 error. Ooh, what's up?
So for this question, are you saying that your statistical analysis got you to accepting the research hypothesis, but because of maybe like a sample error, you're assuming that your research might be wrong?
Absolutely. Absolutely. So here's the thing. I think about a type 1 as, and I don't know that I've ever seen this in print, but I think about it like arrogance. So a number of statistical consequences follow. If I take a giant sample, huge sample, and I want to calculate my standard error. My standard error is going to be sigma over square root of n. I take sigma over something huge. What's going to happen to the value of my standard error? If my denominator is huge, what happens to this thing as a whole? Does it get bigger or smaller? Smaller. This big sample size, n is big, leads to a small standard error. Okay. If my test statistic is my sampling error over my standard error, and my standard error is small, a small denominator, what happens to my test statistic? Does it get small or big? Small on the bottom, fractions. The entire thing gets bigger. So if I have a big test statistic and I've set up a hypothesis test, doesn't matter if it's 1 or 2 tails. Doesn't matter if my test statistic is negative or positive. What I'm saying is that it's big. Somewhere over here or over here. Mike, do I accept or reject the null if my test statistic is over here? What happens to the null? Yeah, we're going to reject the null. And if we reject the null, we accept the research hypothesis, which is where this whole thing started. We start with accepting the research hypothesis. But nowhere in this story did I say anything about an effect, about sampling error, about what we observed versus what we expected. The only comment I made was that we started with a large sample size. So now I go back to this being a type 1 error, an error of arrogance. If I think I know everything, if I have observed everything I can observe, if I'm so confident that I know everything about what's happening in the world, it's going to be very easy for me to see that you're different from, you're all different because I know everything. That's a bit of arrogance. And when that results in an error, it's a type 1 error. That results from the perception that you have observed everything. A large sample size, an excessively large sample size, will lead to a type 1 error. Contrast that with when we get to type 2 error, the effective sample size there. So in this case, Abby, what was the answer? A. So H sub naught is true, but we rejected it. We rejected it, but it's true. Sounds good. A type 2 error Abby, you know this one too? Shouldn't be that one, because that's what you just told me.
Yeah. Is it food?
HO is false. Well, if HO is false, then there is a real effect, and we fail to reject H naught. So we fail to reject H naught and accept it. We accept something that's false. Looks good to me. You commit a type 2 error, which I call the opposite of arrogance or ignorance. You might commit a type 2 error, an error of ignorance, if you haven't observed enough. If you haven't had any exposure to the world, if your sample size is so small that you can't tell the difference between one thing and the next. If we had only ever worked on 2 total hypothesis testing problems, they would probably look the same, regardless of what was different, because the only thing that you see is the fact that they're hypothesis testing problems. But when you see 10 or 20 or 30 or more hypothesis testing problems, then you start to see what's unique and different about them. Ah, this one has sigma where this one doesn't. Ah, this one's about pi, whereas that one's about mu. A type 2 error is an error of ignorance, where you say, you know what, everything's the same, likely because n is small. So now here's where we move on. I lost track of what question number this is because mine aren't numbered. This is 7? Thank you. Who's that coming from? All right, so type 1 error. What do we do in a type 1 error? So much of this is about language, Dan. Type 1, failing to claim an effect when it actually exists. Failing to claim an effect would be accepting H naught. But in a type 1 error, we rejected H naught. Here, we failed to claim an effect, so we accepted H naught. I have to remove A, I believe. Try again for me. Does not actually exist. B, correct. Bless you. Yep, that's what a type 1 error is. Type 1 error says everything, that's an effect, that's an effect, did you know if you observed everything everywhere possible, everything would look different. Every statistical test would say nothing has any similarities. That's not a byproduct of reality, that's a byproduct of the statistical test. In reality, most of us are pretty similar. We got a lot in common. Eight. All right. Redemption time, Dan. Failing to claim an effect. That means we accept H naught. Well, if it actually exists, we should have rejected it. 8 is D for Dan. Well done. Thank you. 8 down, 80% to go. Uh-oh. We have to be able to turn 0.05 into 1 out of something. 0.05 is 1 out of what?
20.
Thank you, Jimmy. 1 out of 20. So in that question, which says, oh, whatever it says, the risk of committing a type 1 error, which is called alpha. If that is set at 0.05, that means that 1 out of 20 studies might have a bogus effect. Type 1 error, what's the name for type 1 error? Alpha or beta? Alpha indeed. Alpha looks like that leftward swimming fish. not the rightward swimming fish. Do y'all know this story about the fish? Nobody knows this story? I don't know if it's true, but back when I was a kid, I used to go to some camps, and one of the symbols that we used there was the fish, was the Jesus fish. And the story of the Jesus fish, so far as it was told to me, is that back in the day when people had to keep their Jesus on the down low, if you wanted to know whether or not someone subscribed to your religion, let's say, you would do this with your foot. You'd make half a fish, and if somebody else also believed what you believed, they would complete the other half of the fish, and then the two of you would put your two little arcs together, and it would make a fish, the symbol of swimming, or in this case, type 1 error. Anyway. Little knowledge, I thought that was cool. I figured I'd share. But that's your alpha. It looks like an A. It's a leftward swimming fish. Okay, type of committing type 2 error. We're calling this probably alpha again because they all say no. Sorry? Yep. It looks like a B. Sometimes it get a little curvy up there. Maybe you'll get a little bit in there like that. It's like a script B that's not, I don't even know how to write a cursive B anymore. That's not it. Looks like an ampersand with a deformity on its head. Certainly not a Hershey kiss in the beta. RJ, what are we on? 11?
We just asked.
12, thank you. 12, sample size is the most influential factor in calculating statistical power. Statistical power being your ability to detect an effect if it exists. Sample size is the most influential factor in calculating statistical because, who wants to take a crack at it? Emily. Well, sample size helps us. Yeah, we go with C under the control of the researcher because if I think an effect size is small, I know that as a researcher I should collect a large sample. If I believe an effect is obvious or easy to detect, I don't need a large sample to tell my story. But when we do work on how many people we should observe, you calculate power for the effect first. 12 down. More to go. As the probability of committing a type 1 or alpha error goes up, what do you suppose happens to beta? Ryan? I think it goes down too, and it does. It's a trade-off. Like, how willing are you to accept that an effect is real versus how willing are you to accept the fact that it's not? How willing are you to say, I have to be right about this, or I better not miss anything? That's always the trade-off there. As that goes up, this goes down. 13. We're cruising today. You guys must have had your monster before you showed up. Welcome to the 21st century, guys. A large effect size blank to detect a difference between the sample statistic and hypothesized population. So if an effect size is large, it's either easier, more difficult, does not change your testability, or raises uncertainty in a hypothesis testability. If we have a big effect size, is it easy to detect? Something is very obvious. For example, I don't know, no bad Jeff, no weird examples. Let's see what you can come up with. Jimmy, what do you think? Yeah, I think so, yeah. Because our test statistic, Z, is what's going to end up in one of these tails or not. Part of our test statistic has to do with the sample size, because the sample size goes into the standard error. But what you observe minus what you expect goes on top. And if those two things are very close to one another, we have a small effect size. A small effect size, that's kind of what that is. A small effect size means we're not that different from what we expect. A small effect size means we're not that different from what we expect. But a big effect size, we don't need a big sample. We don't need a small standard error, because a big effect size means we'll end up over on one of the tails regardless. A big effect size makes it easier. 14. A non-directional hypothesis test is known as, Cat? Yep. And now this is the point where Jeff pontificates pointlessly for the next 2 minutes. Boo that. Boo it, and I won't do it. So here's the thing about two-tailed tests. I don't know, I can talk over those boos. So a two-tailed test is like non-directional because it can go one direction or it can go the other direction. And that's what makes it you are horrible at booing. There you go. That's what I think. As long as it's not an empty beer bottle, I'm all right. You got a full one? Two-tailed test, non-directional, 15. Moving on. 16. A directional test is known as a one-tailed test. Oh, looks like that. Because in a one, now we'll still start booing everything, but that was appropriate boo. That was appropriate boo. Yeah, one-tailed test. Got one tail. All right, moving on. I can do that. See, I can speed up a little bit. There was this one time when I started going really slow. Yeah. You should figure out when the right time is. That's my change for next semester, is I'm gonna be like, all right, if I'm going too slow, boo me, and I'll keep moving. That's how Steve Martin learned. What's up, Giannis? In the hypothesis test, the pair of hypotheses state the purpose of the test. The equal sign is always, you want to say the equal sign. Which one always attains equality? One of them always contains equality. Which one always attains? Whether it's less than equal to, greater than equal to, or just plain equal to? A, yeah, the null. So H sub 0 or the null. Is that 117?
Yeah.
Cool. Thank you. Uh-oh. In a two-tailed hypothesis test, which one of the following is likely to be the research? Could that be the research hypothesis ever? Mu equals 100? No. I wish I had the ability to write the does not equal symbol in Sakai all the time. It could be that one. Let's just see what the other ones are so we can not choose them. Yeah, those both appear to be one-tailed or directional. 18 is B. Questions on directionality hypotheses? Hope not. Maybe. Slow me down if you want. Okay. In a right tail hypothesis, which one of those is the research hypothesis in a right tail hypothesis, Lizzie? C. How do you remember that C is that side? Greater than is on the right side. Yep. This is the greater than side. That's just greater than side, and that piece looks like that. 18 is C. Oh wait, this is 19?
Yeah.
All right, sorry. 19 is C. I was joking. Right? Yeah, you're right. Thank you. I believe you. I just am ignorant sometimes. 20. What's a left tail hypothesis look like? Lizzie, can you do this one for me too? Yes, you can, because a left tail hypothesis, that looks like that. 20 down, about halfway to go. 21. A researcher hypothesized that a group of clinical depression patients have higher depression scores than the overall population. Is this a one-tailed test or a two-tailed test? Lizzie? It's a one-tailed test. Now, it's got to be on the left or the right. How did you know? What is the word that indicates to you that it better be a one-tailed test, Lizzie? Higher. That's a directional word, which means it's going to be either left-tailed or right-tailed, but not false memory or two-tailed. All right. Lizzie's voice is getting tired. I need somebody else to tell me if it's on the left or the right. Higher. If it's saying, is one thing higher than the other? It would be a right tail. Thank you. Whoa, we're halfway there. I'm going to run out of pencil lead before we get there. An organizational psychologist implemented new leadership training for store managers. The psychologist wants to test if the leadership training has made a difference in stores managers' management style. I want to know if this is a two-tailed, left-tailed, right-tailed, or eyewitness's mistake. Victoria?
Is it two-tailed?
Is it? I don't know. You're the one giving me the answers. I think it is too. How do you know? What's the key word?
It
Does say difference. It doesn't say, I want to know if this training has improved, has made things go higher, or made things worse. All it says is difference. Two-tailed test. 22's A. We good? Cool. 22. A. '23. A high school math teacher believes that frequent quizzes help improve retention of math knowledge. Not just him, a lot of us do. He hypothesizes that the average SAT math score of his students is higher than the average SAT score of the normal population. I feel like we would have done that question by now. Left tail, right tail, two tail, or non-directional. Well, that sort of sells itself, doesn't it? Yeah. Right tail. What's the key word for that one tail aspect? Yeah. Says the research hypothesis is the true mean of his greater than what the normal people do. Right tail. 23. 24. The significance level. What's the symbol for significance level? Thank you. Alpha helps identify what? Population standard deviation? It's totally the answer. No, I was joking. All right, I'm going to get rid of one of those for you. Yeah, keep coming, Yanni.
Is it the test statistic?
No, it's not. Kind of glad you said that. Not because I'm glad you're wrong. I like it when you're right, but this helps us build something. The critical value is what alpha does for us. Because when we go to our table, we have to go to one tail or two tail, pick the alpha, and get the critical value. Critical value requires alpha and the table. The test statistic comes from the formula. For example, and no part of the formula includes alpha. Alpha gives us our critical value. And what does our critical value help us put on our picture? the rejection zone, where we would reject the null. Alpha tells us about the critical value in the region of rejection. The test statistic comes from what we observe. So I might call it the region of rejection where we reject the null. Your textbook author might call it the rejection zone. I think as long as we don't let Kanye in there, we're fine. Thank you. I was waiting for that one. 25. All right. We're going to go through the 4 steps of the hypothesis testing procedure. What's the first thing we do in a hypothesis testing procedure? Step 1 is make the correct conclusion. Ooh. Durbin, you got a smile. Explicitly state our pair of hypotheses. Yeah, 25 is B. Explicitly state those hypotheses. Try to keep your language PG or simpler. Don't be that explicit. You never know who's going to read them. (26). Step 2. Step 2. The second step to a hypothesis test is to. Lizzie's carrying us today. Somebody help Lizzie out. Victoria.
Is it make the correct identify the rejections of
Yeah, alpha, all that stuff. Step 2 is rejection zone, is critical value. Step 1 is state your. Step 1, write your hypotheses. Step 2, critical value. Step 3 after critical value is, Dan? Find the test statistic. Let's see if there's anything on here in 27 that looks like test statistic. We got anything like that?
Yeah.
Oh, hey. 27 is A. So step 1 is your hypothesis. State your hypothesis. Step 2 is come up with the critical value. Rejection zone. Alpha, all that stuff. 3 is test the statistic. And ultimately, step 4
Is the correct conclusion.
Yeah, let's conclude with the conclusion. 28B. Yep, looking good. One of these days we'll write a song about this and no one will ever forget the 4 steps of the hypothesis testing procedure. If anybody wants to lay down a hot beat for me, we can make a banger sometime and then we'll go into the club one day and people will be like, oh my God, we wrote that song. (29) Which of the following words found in the problem statement would indicate a two-tailed hypothesis? Allie? Different. See? 29 down, 12 to go. If there's 41. If there's more than 41, I have no idea how many to go. 44? That's new. The rejection zone is bounded by what, Fabian? That's exactly right. Our rejection zone or zones, well, they go off infinitely, but they do have boundaries at the critical values. 29 down, 30 down. All right, a two-tailed hypothesis test with alpha equals 0.05. So we're going to go to the table if we need to, but I don't know that we need to. First of all, if it's a two-tailed test, which of these two can we easily eliminate? Drew,
A and B.
why can we eliminate A and B? Right, A and B both indicate one direction hypothesis. There's no absolute value saying that it's just the distance we care about. In the first two there, we care about distance and direction. And both of those, we're talking about something being on that side. It's a two-tail hypothesis where alpha equals 0.05. If alpha equals 0.05 and there's 5% in the tail, how much is left in the middle? 5% in the tail, what's left in the middle? 95%. And if I think back to the empirical rule, and I say, given a normal distribution, 95% of stuff, or about 95% of stuff, should lie within how many standard scores of the mean, Jimmy? Should be about 2. I don't see 2 up there. Math is hard, I give up.
1.96.
Yeah, I agree. 1.96 is pretty close. If you use the table, you can get that same answer, but that's not about us using the table today. We're applying concepts. 95% of stuff is within about 2 standard deviations or 2 standard errors or 2 standard scores. 2 Z's, 31. Okay, what is the rejection zone for a left-tailed hypothesis? These are god-awful today. My apologies. I know some of you are throwing up in your mouth right now. All right. Which 2 can we eliminate off the bat, but not on the basis of my gross picture? Emily? Why C and D? Both of these, thank you very much, both of those are bad because they indicate a positive direction, and that's bad. So it's going to be either that one or that one. We have to decide which one of those it's going to be. Anybody have a guess as to which one it is, 1.65 or 2.33, Fabian? B, 2.33? I agree. Yeah, 1.645 would do the same thing, like 95% is within 2 standard deviations, 1.96. 1.65 does 90%. So as 1.65 or those numbers get smaller, we get less percent. But in this case, alpha is 0.01, very small. So it should be a larger magnitude z-score, a value greater than 1.96, because we're getting further away. 99%, where 50% is on this side. This is 0.49. 32 is only on Bravo. Means B. I was making reference to the channel Top Chef is on. That's a great show. All right. We now have to come up with a rejection zone for a right-tailed hypothesis. What alpha is 0.05. We've got a couple options here. Remember in the previous problem, we said if we have a one-tailed hypothesis with alpha is 0.01, we got 2.33. To me, that indicates 2.33 is probably the wrong answer here. We might be on a different side, but that shouldn't affect the magnitude. I'm going to do that for you and get rid of 2.33. Who can get rid of another one for me? Drew? I know. I want you to get rid of another one for me. I want us to develop our critical thinking skills in a logical fashion.
Get rid of B.
Why is that?
It's bigger than A.
It's even bigger. We can get rid of A because of the previous problem. We can get rid of B because it's bigger than the previous problem. And that leaves us with a choice of either 1.65 or 1.96. if this alpha is 0.05, consistent with that, what's the area here? Why, the area is 0.45. And if I had 45% on one side and 45% on the other, do I have 95% in between 45 and 45? What's 45 plus 45? 90. Is 90 95? Nope. Problem 31, we got done saying 1.96 is what we use for 95. We're using the previous answers and process of elimination to get to 1.65. You can look it up in the table if that's what makes you comfortable. And by all means, if you want one, I brought some. I don't know if I have enough for everybody. That's why I didn't bring them out. But I found an envelope with them in there. What's
I
up?
have a question. So if it's 0.45 on the left, wouldn't it be 0.5 on the right?
Mm-hmm.
Wouldn't that be 95 or no?
Well, if it's... Oh, we're on a right tail hypothesis. So I'm on the wrong side, by the way. All that was on the wrong side. But it's the same thing. We put our alpha over here, 0.05, 0.45 here. And sure, there's still 0.5 everything on the left side, right? But it's not talking about, let's start here and go all that way and get to 95%. 1.96 positive, 1.96 negative, or as you're looking positive and negative. You got to go between those two to get 95%. Here, we've got 5% over here. And if we did the same thing on the other side, we would have 90% between the two, as opposed to 95% between the two. 33. See. What's up, Ryan?
When we get a specimen list, are we need a Z table or are we expecting to do it out?
Oh, no. Yeah, man. You totally got tables coming your way. That's the... Yeah, I got a whole bunch of them. If anybody wants one, I printed them up so that not only is there a Z table on here, but there's a Z table on the back. So now you get one of those. Oh, everybody wants it now. I know, we've been wanting them for a while. All right. How nice that we take a break with like 10 questions to go. Everybody who just wants to sprint to their finishes.
Good question.
Yeah, good one though. But it's in color. I think what you meant to say, Ryan, was thank you, but.
Yeah, thank you.
Oh, yeah. You know what? Oh, no. Now that I handed them out to some, I feel like I got to hand it out to everybody. I can't just not. 2, 3, 4, 5. If anybody wants to read the next question, I'm all for going ahead. Uh-oh. Exactly. I have. I have 4 left and a color one-sided one. Chris is going to jump on that grenade. All right. Now we got, okay, good. Now we're back up to 6. Maybe just a minute. All right, I don't know. Dan and Kat, if the ones don't get to you, I'm sorry. I'm still here for you. You haven't lost me. I just didn't have an extra table for you. I'm just laying around. All right. What was the question, Fabian? All right. 34. The basic principle of a test statistic is to calculate the difference between a sample statistic and a hypothesized population parameter, which is otherwise known as sampling error. Statistics scares people away. Sampling error divided by what gets you a test statistic? Sampling error divided by standard error. That's not standard error. That's not standard error. That's not standard error. I want somebody to go back through and watch this video when we're all done. Count how many times a pencil lead breaks. Like, I don't know. Have a Dr. Pepper every time it breaks. So here's the thing that we don't, I don't spend with our introduction to this a whole lot of time on the nature of the difference between these types of things. Oh no, different one. Well, so those of you who are in the 130 class may have heard Tom ask the question about what's the difference between fail to reject versus accept the null. Now, your textbook does give a pretty good treatise into this. The statistical test is only ever enough evidence to reject or ultimately not reject the null. As we looked at early on with alpha error, if you get a large enough sample, you will reject the null, like always, because your sample's big. It makes your standard error small, makes your test statistic large, and then it doesn't matter what your critical value is, because with a large enough test statistic, you'll reject any null. But we have to talk about failure to accept the null, or sorry, failure to reject the null, and failure to accept the research, because it's the logic we build, the innocent until proven guilty, and then what is our evidence? We can't necessarily say that the null is true or is not. We just simply reject it based on the evidence or suggest we don't currently have enough evidence to reject it. But reject and fail to reject are mutually exclusive. And what makes things mutually exclusive? Yeah, they can't be at the same time. Two decisions can be true at the same time. Two decisions can be wrong at the same time. Well, I don't know. Chris, what's the answer? Yeah, when one is true, the other can't be true. Two decisions can be wrong at the same time. Topical humor. 35. Where are we here? 36. 36. Fail to reject the null is a technically precise term that I just declared is not synonymous with accept the null. They are not synonyms, but they're effectively the same thing. Similar, but some people are going to say, Jeff, you're teaching them wrong. Well, I'm looking for your understanding, and when your understanding is strong enough that we can make the distinction between failure to reject and accept, you'll come to that conclusion on your own. I'm not trying to force that logical double negative on you. What I want you to understand is that the mutual exclusivity means that some things happen, that means something else can't happen, and vice versa. So to simply say dichotomously, accept one, reject the other, that's the story I want you to understand. But the language of failure to reject is still important, rather not functional for us, though. But failure to reject the null is precise because what? Because sample size, because evidence, because we have to figure out whether or not we have enough evidence to support the claim. Sorry, not enough evidence to support the claim, or having enough evidence to support the claim. Lizzie? Yeah. We don't reject because we don't have enough evidence. But like I said, with a large enough sample size, you always have enough evidence. The sample size is basically your evidence. But if the evidence is obvious, you don't need a lot of it. Like, if you have one bloody glove with the knife attached to it, along with like the plans to commit the murder, You may only have one observation, but it's a rather damning observation. On the other hand, if you have to go through that CSI stuff and get Abby to hack the mainframe and do all that stuff, like, that's different. That's lots of little pieces of evidence. That's lots of observations. $37. Trying to trick you. Be warned. 37. A running coach believes that his training system for sprinters at his high school is helping to improve his runners' performance. Among high school male runners in his state, the mean time for runners is normally distributed at a mean of 13.2 seconds, which is the correct statement for the alternative, alternate, or research hypothesis, H1. That mu does not equal 13.2, that mu equals 13.2, that mu is greater than 13.2, or that mu is less than 13.2. What means faster? Fabian? Say again?
Never mind.
Yeah, I came closer because I couldn't hear you. But
Sorry.
if you don't repeat what you just said, that's fine.
I was thinking C.
You were saying, is it C? But I didn't hear you when you said that. Okay. Ryan?
But it's a race of time, so it's more shorter time, the faster.
Yeah, that's the trick question. When it comes to races, slower is not better. Faster is better. Fast is a rate of distance over time. We want a smaller time for the same distance. That means an increase in speed. This, since we're talking about time, is correct, rather than is mu, if it were miles per hour, greater than like 15.6. By the way, the average offensive lineman in the NFL, top speed of about 16 miles an hour. Them 340-pound guys can run faster than probably anyone in this room. That's scary. Anyway, 37 is D, because time in a race should be smaller for speed. $38. A pharmaceutical company wishes to put a drug on the market which they believe increases IC. The population's IC is mu equals 100. What would the hypothesis statement for H1 be? Which is different from the hypothesis for H1N1, in which case it would not be, it would bird. How do we state a directional hypothesis here? Why am I choosing a directional hypothesis? Thank you. Why am I choosing a directional hypothesis, Yanni? What's the keyword? Increases. So which of those is a directional hypothesis denoting an increase in IC? There you go. 38, C. 39. Reject the null is a technically precise terms. That means what? Now this is similar to the other one which said fail to reject. Jimmy? Yeah, we've got enough evidence that we should be rejecting that. We've got enough evidence to say that's not the same. 39C. Why does it say A? I wonder if that's an answer key thing, or we're reading the question wrong. If that's the case, I agree with you, Jimmy. Means the evidence is strong enough to support the claim. That's why I reject, because we got strong evidence, right? Like this is an answer key thing, right? Like we got this.
Claim is talking about like the research hypothesis, right?
Right. Or either way, we're supporting the claim. but we got to have evidence to support it. Yeah. All right. No. There's answer key problems from time to time. Anyone who sends me, no, anyone who sends an email. I'll try to remember to do that. But when I don't, you know what happens. Oh, you should put the right answer because I'm going to update the answer key if someone reminds me. Anybody call dibs? Alan, if you don't mind, just send me a quick one. Tell me 39 is C. You don't have to write and follow email etiquette or anything. Just 39C is fine with me. Appreciate that. Thank you. 40. I thought we were almost done, but we're not because we got 44 to do apparently. 40. A non-directional hypothesis is a two-tailed test. Kat?
True.
I think your hand was in the air before I was ready to read it. That's good. Let's push the pace, shall we? 40 is true. Except the null is analogous to fail to reject the null, and they can be used interchangeably. Accept the null and fail to reject. So here's that question which we mark false. Again, they are not perfectly synonymous. It's like saying that teal and cerulean are the same color. Yes, they're both blue, but one is ugly. Which one is ugly? I don't know. They're pretty similar. And like I said, right now, I'm just trying to get you to get good at it. And when you understand what fail to reject means, it will be your own epiphany. And I don't want to steal that from you. And that one was 41. I think so too. When a standard error is large, all right, that means I must be talking about a sampling over standard error thing. When standard error is large, it is more likely to detect an effect when it actually exists. Are we likely to reject the null? Are we likely to detect an effect if we have a large standard error? Will we detect anything with a large standard error? Will we ever get a test statistic of magnitude? Will we get anything up there that's greater than 2, greater than 1.5 if the denominator is massive? The conclusion here is no. A big standard error means we're not going to detect anything. We're going to be missing the boat a lot. False. 43. Reject the null and fail to reject the null are mutually exclusive and collectively exhaustive. You either reject the null or you fail to reject the null. Yeah. 44. When conducting a two-tailed test, the probability of committing a type 1 error, alpha, is to be evenly divided into two tails, alpha over 2. What do you say, Chris?
2.
So does the answer key. All right. So we just knocked out 44 questions in an hour. Well done. So that's the homework. I said I was going to stick around for another 45 minutes or something if anybody wants to do any practice problems. Now updated on Sakai in both Module 7 and Module 8 are 2 assignments. At the bottom of 7, you can see hypothesis testing practice. At the bottom of, oh, shoot. At the bottom of 8, confidence interval practice. These are the assignments that I used in past semesters to help people get a lot of practice for these things. And they were actually the assignments that led to the creation of me doing the homework help videos. So I've got a couple videos for these laying around, which I can post as well if you want to work along with them. But I've never said that the homework help videos are as good as doing stuff with. So if anybody wants to work on hypothesis testing problems or confidence interval problems, let me know, because we got a whole bunch that we can look at and do lots of practice if you want to. Or whatever. Good day today, guys. Thanks for playing along. I'm going to start with Steve Martin jokes from now on. Oh, yeah. Yeah, not everybody was happy with 184 questions. But it's basically 12 questions with 12 parts and another bunch of multiple choice and true false. So what? Yeah. Yeah, there's a lot. It looks like a lot of questions, but it's the same thing where there's like 10 or 12 parts, because I don't want you to just say reject the null, move to the next question, because that's not learning.
Yeah.
Thank you. You get our classes? I think I asked you. Yeah.
What? Oh, no, I got my cab right away, but the intro to financial session, like it said, like.
As I think as a freshman you can.
Yeah.
Did you get your 204 straightened out?
Yeah.
No, you were part of that group, were
I
you?
go through registered for it, so.
Oh, all right.
Yeah, it's on my course description. I'm running it.
There were a good 10 or 15 people who were unable to get in.